where to begin? That is always the question with time. When measuring space, one has the advantage of a God's eye view. We can encompass it whole, from beginning to end, parceled into discrete shapes. But time, at least we assume, is different. Time has no hills, no valleys, no fields or hedges. It isn't even really a line, but a blurry, floating patch of reality around a point called now. A circle has no beginning and no end. A square is the same from any side. But time, to be measured, must have a beginning. So, which should we choose? Perhaps, as the Mad Hatter suggested, we should begin at the beginning. It is, I think, somewhat unfortunate that physicists the world over decided to appropriate Sir Fred Hoyle's disparaging label of Big Bang for the currently accepted model of cosmic origins. Hoyle, who, even till his death in 2001, never accepted the idea, intended the term as an insult, and insults, however cutting, make terrible descriptors. The Big Bang was not an explosion. It was a massive increase in volume, an expansion of space into nothing. Not void, not emptiness, nothing. This expansion carried with it not just matter, but the space and time in which to hold it. Time and space, according to Einstein, are not separate, but interwoven into a four-dimensional cloth called space-time. Before the Big Bang, there was no space, and thus no time. If time existed before the Big Bang, then it was not our time. The data are a bit confusing at present, but broadly we can say that the Big Bang occurred sometime between 13 and 14 billion years ago. Or can we? What do we mean when we say a year? The revolution of a planet not yet formed, around a star not yet born, in a galaxy yet to coalesce? Is that not a strange fit for the dawn of time? Perhaps instead we should look to a time closer to our own. Let 9.5 billion years pass. Galaxies come together, and within them stars are born, live, and die. Eventually, galaxies end their violent, raging adolescences and settle into comfortable middle age. And somewhere in the outer regions of a reasonably sized galaxy, at the tail end of a gigantic galactic cluster, another star is born. It is a fairly impressive star, larger than 90% of the stars in the universe, but nowhere near as large as stars can get. Someday, some will call it the Sun. The Sun's birth cries rage into the vortex around it, blasting it with superheated particles and radiation. 10 million years have passed since its formation. The largest of its planets are already established. But, closer in, chaos still reigns. A traveler to the innermost region of the solar system would have seen not 4 planets, but dozens. Some the size of the Moon, some the size of Mars, jostling and colliding with each other as they careered around their child parent. These collisions are beyond human understanding. Each is large enough to reduce both impactors to liquid. As the number of planetary embryos falls, 4 objects that might be called planets begin to emerge from the rubble. For the 3rd planet out, however, the nightmare is not over. A final planetary embryo slams into it, annihilating its newborn surface and reducing it once again to a sea of magma. A cloud of gaseous rock enters orbit around this young planet, cools, and becomes a satellite, the Moon. But eventually, Earth's surface cools once again, and its motion finally becomes that of a solid object. There is no one, and indeed nothing, to stand and observe the Sun's passage through this new planet's sky, but whenever and however it occurs, it is the first day. It is a day in hell. A bare landscape of jagged, black basaltic ridges baking under a blanket of carbon dioxide, torn apart by roiling magma seas and pelted with city-sized rocks that would one day become the ocean. The Moon, if it is visible at all in the blackened, dust-choked sky, is a great, swollen red eye, 10 times larger in the sky than today, though its eccentric orbit means its size can shrink and swell by up to 5 times as it swings around the Earth. The day is also short. Earth's rotational speed is striking even today. The equator spins at nearly 17,000 kilometers per hour. In this infernal dawn, the Earth speeds nearly 5 times faster, and the day and night cycle in just 5 hours. The looming moon raises monstrous tides on the Earth's surface, which gradually tame and regularize its orbit, and unleash the newly born ocean onto the land in raging tidal bores, dwarfing anything seen today. These tides pull the ocean across the planet's surface, draining it of its rotational energy and slowing it down. By 4 billion years ago, a day was 12 hours long. If the dinosaurs had had clocks or calendars, they would have measured a year of 380 23-hour days. As the moon wrestled with the young Earth, Newton's laws demanded an opposite reaction, and it began to retreat. It is still retreating now. Mirrors left on the moon by the Apollo astronauts allow astronomers to use lasers to take exceptionally precise measurements of its distance from the Earth, and they show that it is gradually moving away at a speed of roughly 3.8 centimeters per year. In 600 million years, the moon will be too far away for total solar eclipses to occur, and the day will be 27 hours long. The moon governs our time at nearly every level. It was and is our first clock. As it orbits the Earth, its angle to the sun's light shifts, casting different parts of it into darkness at different times. Sped up, the moon appears to be gradually swallowed by a rotating shadow, which then passes behind its facing side and then circles back again. This regular, eternal cycle of shadow and light, the month or month, is as dependable as the tick of a second, only 29.5 days long. It is possible our ancestors used the moon to time their lives before they were even human, as many animals do today. Corals spawn in unison just after a full moon. Petrels time their migrations to the full moon. Even annelid worms time their reproduction to the lunar cycle. Across history, the moon's importance as a timepiece outshines, if you'll pardon the metaphor, its every other aspect. In Genesis chapter 1, God places the sun and the moon in the sky not to give light and heat, but to count time. The moon's very name is tied to its role as a timekeeper. 6,000 years ago, the Proto-Indo-Europeans, the mysterious group of half-nomadic raiders whose language would one day evolve into English, French, Russian, Welsh, Iranian, and Hindi, called the moon, and forgive the pronunciation, Mayans, which likely means measurer. Paleolithic man, despite a deeply artistic soul, left no unequivocal depictions of the sun or moon behind. The earliest confirmed solar and lunar symbols postdate the invention of writing. But there is evidence that even he was conscious of the moon's utility. Across Africa and Europe are scattered a number of notched bones that appear to track the moon's changing face. The 44,000-year-old Lebombo bone, found in South Africa, is marked with 29 individual notches, the number of days in a lunar month. The 20,000-year-old Ishango bone, found in the Congo, contains a series of 48, 60, and 60 notches, all numbers divisible by 12, the number of months in the modern calendar. The 25,000-year-old Venus of Lausel depicts your standard Stone Age thick girl holding a crescent-shaped horn with 13 notches, the number of months in a lunar calendar. If this is the case, it would mark the earliest known depiction of the moon. A 13,000-year-old bone found near the French village of Le Placard shows a series of tallies separated by the unusual divisor of 7. Could this be because 28, or 4 times 7, is an approximate value of the lunar month? This may all be coincidence, of course, but one other aspect that ties these bones together is that they are all of animals, such as eagles or baboons, that are not a standard part of the human diet. These people were intensely tuned to natural cycles. They had to be. Knowing what time of year the deer and geese migrated, the salmon spawned, and the fruits and grains ripened would have been the difference between survival and starvation. To this day, many hunter-gatherer societies name their months after the various bounties they could harvest within them, such as spawning month, corn month, or geese month. A lunar calendar would have been a useful tool in humanity's mental toolbox, allowing us some degree of control over our unforgiving world. Except, it was wrong. A 12-month lunar year comes to a total of 354 days. But even those first timekeepers must have known that the seasons cycled longer than that. This is because the moon, however convenient a clock it may be, does not govern the seasons. The sun does. But while the moon's position can be secured with a single look, the sun's motions are far subtler and require multiple observations from a single fixed point to deduce. The sort of activity one tends to perform in a civilization. As the human race shifted from hunter-gathering to farming, we began to take note of the far more elusive, but also far more vital, motions of the sun. From our perspective, the sun appears to make a daily east-to-west arc across the sky, but also gradually shifts over the course of the year from south to north, and then back again. If we could accelerate the passage of time like H.G. Wells's Time Traveler, the daily motion of the sun would blur into an indistinct band, which would then rise and ebb like the tide with each passing year. The points at which the sun stops and reverses course in its annual path are called the tropics, from the ancient Greek for turning. The times of year when the sun reaches the tropics are known as the solstices, from the Latin for the sun standing still. As the sun approaches the higher tropic, the days lengthen, marking the arrival of summer. As it descends toward the lower tropic, the days shorten, marking the arrival of winter. Many cultures throughout the world have consecrated the solstice times, particularly the winter solstice, as periods of celebration or reflection, celebrating the sun's power but reflecting on its impermanence. The midpoints between the solstices, when the sun's path crosses the celestial equator, are called the equinoxes, from the Latin for equal night, for then the days and nights are of equal length. They mark the start of spring and autumn. Many calendars use solstices or equinoxes to mark the new year. The first month of the Hebrew calendar, Aviv, means spring. When mapped over a year, the sun's motion ascribes a great circle around the earth, tilted at 23.5 degrees from the celestial equator. Ancient Greek astronomers called this great circle the ecliptic, because, since the moon followed it as well, it was where eclipses happened. From a modern perspective, the reason for the seasons is strikingly simple. It's not the sun's motion that is tilted to the equator, it is the Earth itself. Relative to the sun, Earth is tilted at a 23.5 degree angle. As its orbital angle to the sun shifts, the light received by each hemisphere increases and decreases. At one side of its orbit, the northern hemisphere faces the sun, and the pole sees continuous day. At the other, the southern hemisphere faces it, and the North Pole sees continuous night. Thus, the seasons are reversed in each hemisphere. The reason the ancients couldn't accept such a simple explanation is that it required accepting that the Earth moved around the sun. After all, if the Earth is motionless at the center of the universe, then what is the difference between it being tilted and the universe being tilted? It would be centuries, and the discovery of gravity, before the ancients' objections to the motion of the Earth, for example, how the Earth could move yet its atmosphere remained still, were met. The first great civilization, the Sumerians, were also the first to attempt to reconcile and simplify their lunar calendar. They divided their year into 12 months of 30 days each, for a total of 360 days. It was, at least, an improvement over the lunar calendar's 354 days, but still not the familiar 365 of the solar year. The choice of 360 fit their counting system, which was based on 60s and 360s. The Sumerians would pass this system to their successor civilization, the Babylonians, from whom we obtain the first meticulous astronomical records. It is thanks to the Babylonians that today we divide circles into 360 degrees and clock faces into 60 minutes. The Babylonians further divided numbers into ever-decreasing 60-based fractions, the first of which was called a first, the second a second, and so forth. Hence why, after 3,000 years, we still divide time into seconds. Another practice likely handed to the Babylonians from Sumer was declaring the 7th, 14th, 21st, and 28th days of each month unsuitable, quote-unquote, during which certain actions were forbidden. The Hebrews, who borrowed many ideas from Babylon, would adopt that idea as well, and once Alexander led the Eastern and classical worlds together, the Greeks would make the 7 days sacred to the 7 astrological planets: Saturn, Saturday; the Sun, Sunday; the Moon, Monday, Mars; Tuesday, after the Anglo-Saxon god of war; Mercury, Woden's day, after the Anglo-Saxon god of wisdom; Jupiter, Thunor's day, after the Anglo-Saxon god of thunder; and Venus, Frigg's day, after the Anglo-Saxon goddess of love. The Babylonians mapped the sun's path through the year onto 12 constellations, now called the zodiac, which in turn likely inspired them to divide the day into 2 sets of 12 hours. Though unlike the modern 24-hour day, both day and night were divided into 12 hours, so that 12 a.m. occurred at sunrise and 12 p.m. at sunset. An hour, then, was not a fixed time, but varied with the lengthening and shortening of the day over the year. This convention would be the standard for the Western world until the mechanical clock replaced the sundial in the 15th century. The Babylonians were, thanks to their careful astronomy, aware that the solar year equaled 365 days, but reconciling that with their lunar calendar required that the priest decree an additional month, which often occurred at random. But with the realization that 235 lunar months were almost exactly equal to 19 solar years, the randomness disappeared. Now, 7 of every 19 years could be set longer, and 12 shorter. The ancient Greeks attributed the discovery of this coincidence to the philosopher Meton of Athens, and thus today it is known as the Metonic cycle, though the Babylonians certainly discovered it before him. Whether Meton discovered the cycle himself or learned of it from the Babylonians, we don't know. But since it was independently discovered in China, it is possible he found it himself. To this day, both the Hebrew calendar and the Holy Christian calendar, used to calculate the date of Easter, employ the Metonic cycle. Though it was the first calendar to break the spell of the moon, the Babylonian calendar did not ultimately birth the one we Westerners use today. Our calendar was born of 2 parents, one simple, Spartan, and traditional, the other chaotic, aggressive, and dysfunctional. This unlikely marriage was precipitated by an actual marriage, indeed one of the most consequential unions in world history. It is a mark of our modern Western vanity that we grant both Egypt and Rome the title of ancient. By the time of Rome's alleged founding in 753 BC, Egypt had already been a unified nation for over 2,000 years, bar a few messy interregnum periods and invasions. Cleopatra, the last pharaoh, is closer in time to us than to her nation's founding dynasty. And yet, for all that time, Egyptian culture hardly changed at all. Artwork from Egypt's founding period is virtually indistinguishable from artwork from Cleopatra's day, 3,000 years later. Classical Egyptian, only mildly altered from the nation's earliest history, was still used as a literary language even as Egypt became a Roman province. Living as we do in an age of future shock, when even previous decades can seem like alien worlds, it's difficult to comprehend such fanatical cultural conservatism. And yet from Egypt's standpoint, it made sense. Egyptian civilization was geographically blessed. Protected from outside by the ocean to the north and the desert everywhere else, it could afford to ignore the winds of change. Despite seeing virtually no rain, it could rely on the Nile for food, transport, and agriculture. But its greatest blessing, and the source of its vast wealth, occurred once a year at the height of summer, when rains in the Ethiopian highlands sent a massive pulse of water hundreds of miles downstream, causing the Nile to overflow and deposit a layer of black, fertile soil on its banks. This black soil was Egypt's life source. Even Egypt's name in Egyptian was Kumat, the Black Land. For as long as the dates could be harvested and the beer could be brewed, Egypt would prosper. And year after year, like a beating heart, the Nile granted Egypt that prosperity. A culture set to such a dependable clock has no need to change. But no clock is perfect, and if the flood were too weak or too strong, it could spell disaster. It is likely that collective attempts to control and mitigate the effects of the flooding of the Nile led to the development of Egyptian civilization in the first place. One of the first steps toward controlling the Nile's flood is knowing precisely when it will happen. And to this end, the Egyptian scholar-priests devised the first calendar entirely divorced from the moon. As myth tells it, Egypt once possessed a lunar calendar similar to the Sumerians, comprising 360 days divided into 12 30-day months. But when Nut, the sky, mated with Geb, the earth, the sun god Ra became enraged at the thought of his own overthrow and declared that she should not give birth on any day of the year. To get around the problem, Tot, god of wisdom, challenged Ea, the moon, to a game of Senet, a board game similar to checkers, demanding that if he won, the moon grant him 1/72nd of his light. 360 divided by 72 is 5. With the light won from the moon, Tot added 5 extra days to the year, during which Nut birthed the gods Osiris, Isis, Set, Nephthys, and Horus. Eventually Ra got over himself and even rewarded Tot for his guile, and so the power of timekeeping was taken from the moon and given to the sun. This 365-day civil calendar would be the standard reckoning for the Egyptian nation for 3,000 years. Even Ptolemy, writing in the 2nd century AD, referred to a 365-day year as an Egyptian year. But in all that time, no one dared touch it. The myths and magic that had shaped the calendar had rendered its very form holy, and the priests that governed Egypt's affairs refused to tarnish it. Yes, they were aware that the year was in fact closer to 365¼ days long. Their solar observations had confirmed it. But they had also given those priests another clock to track the flood. As the sun moves through the year, its brilliance blocks out the light of half the stars in the sky. Over time, the sun, like a lighthouse beam into the universe, shifts from one side of the sky to the other, and previously hidden stars are gradually made visible. The point at which a star appears from behind the sun is called its heliacal rising, and it just so happened that Sirius, the dog star, the brightest star in the night sky, emerged from hiding at the precise midsummer point at which the Nile flooded. That, by the way, is why midsummer is called the dog days. Over the course of 1,460 years, the Egyptian calendar cycled through every day of the year, until it once again aligned with the heliacal rising of Sirius, which the Egyptians called Sopdet, and the Greeks for some reason transliterated as Sothis. Hence the name for this grand span of time, the Sothic cycle. The ancient Greeks were nothing if not logical. Hell, they coined the word. In 303 BC, Egypt came under the control of the Ptolemies, descendants of Alexander the Great's generals who had assumed power after his sudden death 20 years prior. These Ptolemies are not to be confused with the astronomer Ptolemy, who lived centuries after them and likely took his name from his birth town. The Ptolemies may have ruled Egypt for 300 years, but they were Greek to the core. Cleopatra, the last of their line, was the first to bother to learn Egyptian. They weren't about to be beholden to their subjects' superstitions. In 238 BC, Ptolemy III decided to put an end to Egypt's calendric nonsense. Every 4 years, he decreed, a day shall be added to the year to be celebrated as the Festival of the Good-Doing Gods. He was ignored. Perhaps, though, the people were right to reject him, because centuries later, when the matter of the calendar was finally taken up again, it would presage the final end to the 3,000-year story of Pharaonic Egypt. Cleopatra VII, Philopator, last of the Ptolemies and the last independent ruler of Egypt for over 1,000 years, is almost not a person anymore. She's an icon in the most demeaning sense, reducible to a black fringe and perhaps eyeshadow, though images from her time suggest a far more European, and to our eyes, conservative look, which makes sense since she was Greek. She is presented as a paragon of exotic beauty and luxuriance, though accounts of the time, heavily biased it must be said, portray her as having, at most, average looks, but also a captivating charisma and intelligence that drew in and fascinated experienced, worldly men. Cleopatra's pursuit of these men was ultimately an act of political survival. Against the advance of Rome, Egypt's conservatism had become a liability, and 100 years before had already forced it to become a Roman client state. Cleopatra's father, Ptolemy XII, had put both her and her 10-year-old brother in charge of Egypt upon his death, an arrangement that worked about as well as you'd think it might. And yes, they were married. It's an Egyptian thing. Probably the reason none of King Tut's children survived. Predictably, Within 2 years of assuming power in 49 BC, tween Ptolemy, or rather his advisor Pothinus, the kid was 12, launched a coup against Cleopatra and forced her into exile. If that wasn't enough, her ousters also managed to curry favor with the dictator of the Roman Empire, Julius Caesar, by executing his political rival, Pompey. If Cleopatra was to secure his backing, she would have to do something dramatic. And oh boy, did she. Under cover of night, Cleopatra sneaked into Caesar's guest room hidden in a bedroll, and, just when he was at his most private, unfurled herself in front of him. She had artfully styled her face and hair to give the impression she had been crying for several days, and begged Caesar for his help. This was arguably unnecessary. Caesar suspected Pothinus planned to have him killed, after he demanded the advisor repay a massive debt owed him by the old king, but it certainly impressed him. The couple, according to sources, made love that night. Caesar was already married, but, as noted above, Egyptians did things their own way, and soon he and Cleopatra were married and expecting a child, aptly named Caesarion, or Little Caesar. History likes to paint this as a great romance, but I doubt Cleopatra had any illusions. Caesar was 30 years her senior, epileptic, and balding. This was about power. After a massive banquet, Caesar demanded that Cleo and her brother play nice and rule Egypt together again. But Caesar's barber whispered in his ear that Pothinus was about to kill him, so he and his guards surrounded the table and took him out there and then. One of Pothinus's generals then declared war on Caesar, who, outnumbered and on foreign soil, fought a brutal, protracted conflict that led to the burning of the Library of Alexandria, likely on his orders, an event which must have left the intellectual Cleopatra devastated. But in the end, reinforcements arrived. Her brother died whilst fleeing, her sister Arsinoe, who had taken up arms against her, was taken to Rome in chains, and she ruled Egypt uncontested. Well, except for her other younger brother, whom she poisoned 3 years later, declaring her son by Caesar her co-regent. Caesar returned to Rome in 47 BC with a head bursting with plans. He dissolved corrupt guilds, enacted dozens of new laws, established term limits for elected officials, and forgave a quarter of all Rome's debt. But his greatest and most lasting plan was to reform Rome's decrepit calendar. The most remarkable thing about Rome's calendar wasn't how it functioned, but that it managed to function at all. Even in myth, it was misbegotten. Romulus, Rome's mythical founder, supposedly established the calendar as having just 10 months and lasting just 304 days, which, by the way, is why the 9th, 10th, 11th, and 12th months of the year are named Septem, Octo, Novem, and Decem, i.e. 7, 8, 9, and 10. The Romans were somewhat more imaginative in naming their other months. March, May, and June were named for the gods Mars, Maius, and Juno. April was about raising hogs. January, when it was eventually added, was named after the two-faced god Janus, who looked both forward and back, and thus guarded gates, doorways, and transitions. February comes from a word meaning purification, because a purification ritual was undertaken in that month. With the addition of January and February in 700 BC, the Roman calendar at last caught up with the Stone Age, having a full lunar year of 354 days. Although, since Romans thought even numbers were unlucky, that was lengthened to 355, unwittingly making it more accurate. This same superstition is why February is the shortest month of the year. The calendar's formulators insisted that a month only consist of 29 or 31 days, but there was no way to make the numbers match the total, so one had to be even. Thus, February was stuck with 28 days. At first, the Romans tried to account for the shortfall by adding an extra month every 2 years, but overshot the mark and ended up with a 366-day year. They then tried following the pre-Metonic Greek practice of adding 3 months every 8 years, but, quite frankly, were just incompetent at it. Sometimes priests forgot to insert a month, and sometimes they forgot, conveniently allowing them to shorten the terms of politicians they disliked, or suddenly remember for politicians they favored. Control of the calendar allowed them to dictate when and how much tax could be collected, and on which days it was permitted to perform certain functions. In 304 BC, a civically minded pleb named Flavius, like a pre-Christian Martin Luther, stole the codes used for calculating the calendar and posted them in the Forum, forcing the patricians to relent and publish the calendar every year. This didn't change the fact that the calendar was still under the arbitrary control of often corrupt politicians, including, it must be said, Caesar himself, who, despite holding the role of chief priest for over a decade, had not introduced an intercalary month for 5 years. By 46 BC, the calendar was 117 days out of sync with the seasons. We like to imagine Caesar and Cleopatra's time together as one long, decadent love fest, but it almost certainly would have also included intense intellectual discussion. Caesar was an intelligent man, Cleopatra an intelligent and learned woman. Alexandria, the capital of Egypt, was the greatest center of learning ever established up to that time. Alexandrian astronomers had measured the distance to the moon, calculated the circumference of the earth, and even measured the precession of the equinoxes, a solar motion so subtle it takes 26,000 years to complete. When drafting his new calendar, Caesar turned to one of these astronomers, named Sosigenes. It may have been from Sosigenes that he learned of Ptolemy III's ignored decree, for his final calendar was essentially that decree made law. From now on, the Roman calendar would consist of an Egyptian year of 365 days, but with an additional day every 4 years. Problem solved. Well, not really. Because, remember, the Roman calendar was still 117 days out of sync, which meant that 46 BC, to bring the calendar back into line, had to be 445 days long. This, as you can imagine, caused problems. Shipping schedules were thrown completely to the wind. Tax collectors demanded taxes be assessed for the 2 extra months. Contracts were stretched beyond people's ability to pay. Caesar declared 46 BC Ultimus Annus Confusionis, the last year of confusion. But most Romans just called it Annus Confusionis, the year of confusion. Caesar also shifted the new year from the spring equinox to January 1st. Prior to that, the Roman calendar had gone from the 21st of March 701 to the 22nd of March 702, and regularized the months, ditching the superstition against even numbers, though still keeping February the shortest month, with 29 days and 30 every leap year. The Senate, in a moment of poetry, decided the best way to honor Caesar for his achievement was to name a month, July, after him. That in itself was fine, but when Augustus, his successor, decided he also deserved a month, there was no way he would allow it to be a mere 30 days, so poor February was pillaged again, bringing it back to its original length of 28 days. And so, the union of two awkwardly united people created a union of two awkward calendars, a child better and simpler than either of its parents, to this day called the Julian calendar after its originator. But neither Caesar nor Cleopatra would live to see it flourish. In 44 BC, Caesar was declared Dictator Perpetuo, extending a temporary office to life. This horrified the more democratically minded senators, who rightly feared the fall of their republic. It was to prevent the rise of tyranny that they stabbed Caesar 23 times on the steps of the Senate. But they had not reckoned Caesar's popularity with the people of Rome, who immediately backed his supporters against them. Cleopatra, again playing her cards as best she could, also backed Caesar's faction, which initially proved a good call. But when the victorious Caesarians turned against each other, Cleopatra, either out of necessity or bad luck, backed the wrong horse in Mark Antony. The victory of Antony's foe Octavian, adopted son of Caesar and future Caesar Augustus, left Antony and Cleopatra with a choice of being paraded around Rome in a triumph or suicide. They each chose the latter. Octavian, pragmatic as ever, had Antony's and Cleopatra's official heirs, both children, executed, one of whom, Caesarion, was technically his own brother. Family's always stressful. Caesar's calendar may have presaged the death of the Roman Republic and the Egypt of the pharaohs, but it had resolved millennia of ad hoc, cobbled-together timekeeping. No calendar, however, is perfect, and, however much they may have tried to avoid it, there would come a time when the powers that be would have to contend with the Julian calendar. The gradual, cold realization that the world was living on false time is the subject of the next episode.